Good evening for those who are in Kenya, and also good evening to those on the west, and also is it afternoon those who are in the east. My name is Michael Osunga, and I work at the Kenya Red Cross, and I'll be taking you through today's webinar series. I hope it will be an exciting series, and at the end of it all, my expectation is that all of you will have an opportunity to learn about R, and also a few bit of elements of mapping spatial data. So basically, I'll start off with sharing my screen. Welcome everybody to today's series. So I'll be taking you through how to visualize spatial data in R, but basically, more precisely, I'll be showing you how to visualize vector data in R. Next slide, please. So, like I mentioned before, I work at the Kenya Red Cross Society as the Geoinformation Officer. I hold a master's degree in geoinformation and remote sensing from JKUAT. At the same time, I'm a holder of a bachelor's degree in environmental science from Kenyatta University. And yeah, my favorite programming language is R. So which I basically use for both spatial and non-spatial undertakings. Yeah, next slide, please. So maybe a quick run through of what the International Center for Humanitarian is. Like I mentioned before, it's the research arm of the Kenya Red Cross Society. So it's somehow okay. Now I can
Michael,
share.
Can I pause you for a minute? I have made you a presenter now? Can you just try and see if you can? Let me just stop sharing my screen and then you just share. Yes, that's you.
Yeah, that's me. Thank you so much.
Great. Perfect. So maybe you can just take it from the top, guys. Bear with us, it's a new tool. I do apologize, but now he's ready to go.
Okay. Just a little bit. Just give me a moment.
The thing at the what is this called? The icons opportunity.
A moment. There you go. Yeah, there you go. Sorry for that. So like I was saying, the International Center for Humanitarian Affairs, it's the research arm of the Kenya Red Cross Society.
You can
basically
expand it just a bit. So sorry. Yeah, so that you can see clearly. Yeah. Great.
Yeah, so I don't think if this is the slide you're presenting, Nombo. Is it the same one? But anyway, let me just continue. So the International Center for Humanitarian Affairs is the research arm for the Kenya Red Cross. And it started off a couple of years ago, and its main aim is to improve humanitarian programming through the use of research. So the International Center for Humanitarian Affairs has three key departments, which is now the Research and Learning unit. The second one, where I sit in, we also have a climate research unit, policy and training. So under the Research and Learning unit, I sit at the data section, where I work as the Geoinformation Officer. So under the data section, we have 4 key work streams. The first one is business intelligence. The second one is use of big data, and this is where now GIS falls under. So basically, we use big data to such as satellite images, use of drones to inform humanitarian programming. Then the other one is data and research analytics. And then the last one is data visualization and data storytelling. So my journey in R started a while back in 2014 when I was still working at the Regional Center for Mapping as a remote sensing analyst, where I had an opportunity to visit the University of Maryland to attend the Computational Summer Institute, whereby we had an opportunity to learn R as the Regional Center for Mapping. So it was quite an exciting period, and that's when now I really got the interest in learning more about R. So for this particular webinar, I would want to encourage those of you who use GIS softwares that have graphical user interface, such as QGIS, Saga, and GRASS, to just try to use R for visualizing spatial data. The other thing is, I know also in this forum we have guys who use advanced programming languages such as C++, JavaScript, and Python. Yeah, also I would also want to encourage them to see if they could have a test of R, because ideally they complement one another. They do the same functionalities. So I would also want them to encourage them to use R. So just a quick recap of GIS. I'm sure most of you are not newbies in terms of geoinformation. So before setting up any GIS, it's imperative that you try to understand the 3 components of GIS. So R forms the software basis of GIS, and it's a little bit robust, like I'd mentioned before. So I wouldn't dwell too much on this, but for this particular webinar, I'll be looking at handling vector data, specifically administrative data, just to map out COVID-19 incidences in Kenya, which is something which is a fairly new topic for discussion at the moment, since the beginning of this year. So more specifically, I shall be demonstrating how to load data in R, manipulate. So by manipulating, basically just trying to add a few variables, just try to see how you can clean. And then lastly, I'll demonstrate to you how to visualize this data in R. So the specific packages that I'm going to use are SF and TMaps. So these are some of the most commonly used R packages for visualizing data. So at the Kenya Red Cross, this is what we use the most in visualizing data. So we'll be using data from the Ministry of Health. So basically, this is daily accumulative COVID-19 cases. So at the Kenya Red Cross, we are an auxiliary to the government. So we are trying as much as possible to respond to COVID-19. So on a daily basis, we usually derive maps, static maps, and also interactive maps. So we have dedicated dashboards that we have to get from the Ministry of Health press releases, digitize them, and then we put them in maps, both interactive, and then we share them to Kenya Red Cross program so that at least they can be informed, like they can have a comparative analysis of the spread. So where are we today in all 47 counties? So are the cases rising? Are they stagnating? Are we flattening the curve? Such like things. So I'll be able now to demonstrate how to basically make a simple choropleth map to visualize some discrete or continuous variables. Just so you know, in order for you to choose the type of map you want to make, it's very important that first of all you understand the data type you have. So a choropleth map is ideal for visualizing discrete or continuous variables. Then the other thing is I'll also show you how to use a chorochromatic map to visualize now categorical variables. Then again, for the best visualization of data, I'll take you through a series of classification methods that basically help you to visualize data. So I'll take you through natural lengths, features, standard deviations, equal, quantiles, and so on and so forth. Then lastly, I'll just show you how to create a simple map layout in R. So this is the first series of other series in using R for handling spatial data. But before we move on to the next series, which is the next series, we'll have now to learn how to visualize data first. Yeah, so I'll now open my R Markdown, and basically these are some of the procedures that I'll be taking you through the R Markdown. After this webinar, I shall be able to share with you the R Markdown and the R script as a follow-up. At the same time, I'll also be able to share with you all the resources that you want to take this further, including the data that I use for this specific webinar. So with me is my R Markdown. So I'll try as much as possible to expand it for everybody to see it. So an R Markdown is similar to a Jupyter notebook for those who use Python. Basically, it allows you to document each and every process that you're undertaking in R. So it basically, it's a form of document that you are able to trace your data or GIS workflow in R. So for this particular case, so this is my R Markdown. Basically, the first thing before using an R Markdown is just demonstrate the activities that you're doing. So like I mentioned before, for this particular webinar, I'm going to in a simple way. I'm not going to use any fancy code. At the end of it, all the end justifies the means. So the first thing is to load in some of the R packages that are required for this particular task that I want to do. So I shall be using the SF package, the TMAP. But then again, there are other dependencies. Basically, some packages depend on other packages, so I'll still have to load them. So these are the packages, and I've also created my work folder and so on and so forth. So once I'm done, the first thing would be now to read in my data. So like I had mentioned before, my data is basically a county. It's a county-based shapefile for all the 47 counties, and in all 47 counties now, I have as Kenya Red Cross, we've been able now to cumulatively capture all the COVID-19 incidences from the 13th of March to date. So in order for you to load the data, I've used some of the functions in the SF package in order for me to read my data. So I've been able now to assign my data to an object called Kenya Exposure. So basically, the Kenya Exposure object now contains the information of all the COVID-19 cases spread across the 47 counties. So the first thing one should be able to do in R, before even getting into the nitty-gritties of manipulating the data or even visualizing the data, it's always good to explore your data. The easiest way is to check for data types, because at times you might read in a data and some of the variables might, the columns, they might be converted to factors, or they might be converted to the wrong data format. So it's always good to just look at the data that I've loaded in R. What's the class type? And here I'm just going to use the most commonly used base R functions, like class. So class basically tells you like what kind of R object have you assigned to your R environment. So here you can see that it is it's an SF data frame. I can also, so right now it's a spatial data frame. But then again, if I want to view it, I need to somehow drop the geometry. So a spatial data frame is, in R, it's a data set that has some geometry attached to it. So by virtue of this being a polygon, it means it has a uniform geometry with X, Y coordinates around it. So I would want now to convert it into a data frame or an Excel spreadsheet for me to easily visualize it. So here you use the drop geometry function from the SF package, and you can easily see that I've assigned a new data frame object called Kenya Exposure DF. So if I just open it, you can now see that I have all 47 counties in Kenya. I have a variable called county, and I have also another variable called cases detected. So it has all the cumulative cases for COVID-19 in Kenya from March till let's say late last week. In my environment, I can use the cable function, and if I click on it, at least I'll be able to see for instance, the first 5 rows of my data. So it's just basically trying to look at what data is contained in my spatial data set. Then lastly, I'll also want to see what are some of the data types in my data. So I have county, which is in character format, and the COVID-19 detected cases in my shapefile are in integer format, or they are in continuous or categorical format. So the next thing would be now, how do I manipulate some of this data contained in my spatial data set? So the most commonly used package in R to manipulate data is dplyr. So dplyr, it's a commonly known package in R. So for the R fanatics in this webinar, they can attest. So the dplyr package by Hadley Wickham. So it allows one to do a set of, data manipulation functions using functions such as select. If you want to select a set of columns in your spatial data set, group by, if you want to summarize, maybe you want to do a count of the number of COVID-19 cases in per county, summarize, filter. You can also do some data transformation from wide format to long format using gather, spread. You can also join. So the dplyr function is very powerful. And the good thing about it, it goes hand in hand with the SF package. So it allows you to simply add a pipe, and then after that, consequently, you'd add now a set of functions that you want to do. So I'll give an example. So for instance, in my data set, the Kenya exposure data, the one that contains COVID-19 cases, you could essentially see that I only have 2 columns. The first one is the county names, all 47, and the COVID-19 cases. So if I want to add another variable, I would use the pipe, and then I would say mutate. So basically, I want to add another variable in my spatial data, which is still okay. So basically, these are the same things you could easily implement in ArcGIS, in QGIS, Python, but you can also easily implement in a more simpler way in R programming language. So for instance, if I run this code, it will now allow me to add another column, another variable in my spatial data, which is now the country name. We could easily see the type of data that now, the type of column that I've added in my data, and now you could clearly see on my R markdown that I've added another variable called Kenya. So that's the good thing about R, that you could manipulate your variables, and also you could go a notch higher and also manipulate the values that are contained in your variable. For instance, you could clearly see Kenya as a country is in caps. So I would easily go back to R and say, hey, I want all the Kenya values to be in small cases. So how do I go about it? So I will still go back to my spatial data set, and then I would say still the same variable called country. I would want you to convert it from capital letters to a sentence case, so that at least it begins with a capital letter and the rest remain as lowercase strings. Then again, if I want to visualize it, I'll still drop the geometry and then I will do a visualization of the first rows. And with just one simple line of code, I've been able to somehow, do manipulation of the columns themselves and also the variables contained in the values contained in my columns or in my attribute, as most GIS folks like calling it. So that's basically it about manipulating spatial data using dplyr. So there are other sets of functions that you could also explore later on. So the next session that I want to take you through is classifying your data. So classification generally means generalizing your thematic maps. So it allows you to look at the distribution of your data in your spatial data, and then again see how best you could break it down into several classes and now categorize those class intervals into the number of predefined classes that you've selected. So in spatial analysis, the most commonly used classification methods are Fisher, Jenks, quantile, pretty, equal intervals, standard deviation, and so on and so forth. So before visualizing any spatial data, it's very imperative that you choose a classification method that you'll use across all your maps. Otherwise, you'll be making a series of maps. If you make a series of maps with a consistent classification method, somehow your information is going to be skewed. For instance, if today I make a map using Fisher's classification, I present it to the decision makers, they might see as if the counties with the most COVID-19 cases are fewer than based on my classification model. So at the Kenya Red Cross, the moment we get a request on making choropleth maps, or we usually try as much as possible to use consistent classification methods for our map series. So here I'll just do a summary of what is contained in my data, so that at least you could see the level of distribution of my data of the number of COVID-19 detected cases in Kenya. Then based on this visualization, I will be guided to use a predefined classification method. So like for instance, the COVID-19 cases for my data sets are at 2,655. And the minimum is 0. The first quartile is 1. The mean, the 50% quartile is 114, and the third quartile is 26. So right now, I would want to make a choropleth map that now classifies the COVID-19 cases into low risk, high risk, and medium risk, and high risk, based on a good classification method. Okay. So here, I would want now to break my data, the number of COVID-19 cases across all the 47 counties into 5 classes. And based on this, I'll be able now to know which counties that are at high risk based on the numbers and so on and so forth. So for this particular case, I want to show you how to do a quantile classification in R. So this is my spatial data. And I want to break the number of COVID-19 cases into 5 classes. And this will now inform me on the best way to visualize it, to visualize my data later on. So it's somehow a prerequisite before I delve into visualizing my data. So if I run my script, so I'll use the class interval function. You could easily see that, let me run it. Yeah, so if I do I give a quantile, so I've broken it down into the normal distribution of the data. So my minimum value will be 0 and my maximum will be 2,655. So from here, I will now be able to come up with a new variable, which will break my data into 3 classes, namely low risk, COVID-19 risk, medium risk, and high risk, based on the quantile. So for here, so using this quantile classification, now I've been informed that for low risk counties, this will be the counties that have COVID-19 cases of either 1 or below, okay? Then any case of COVID-19 that is above 1 up to 47, that one would be classified as a medium risk. And anything that is above 47, that will be high COVID-19 risk. Okay, so for this particular case, I've used a simple if-else statement on my data set. So I'm generating a new variable called quantile risk from my data based on the classification method, which is quantile. Okay, so this is just a simple if-else statement, and the low, medium, and high values will go into my quantile risk variable. Then again, for better visualization of my results, I've now mutated another variable called county risk that basically concatenates or like stitches two variables together into one, as you can see. So let me just run it, and then you can see the output from my R markdown. So here you go. So you could see, like you can see on my screen, Turkana has 16 cases of COVID-19, and I've categorized Turkana as a medium risk county because it has how many number of it has COVID-19 cases between 1 and 47. And then again, I've now come up with another variable called county risk that now takes into account the value from county variable and cases detected, and it has put them in one value for easier spatial visualization later on. you'll come later on, you'll come and appreciate why I did this. So that's it about classification. So the next thing, once I've broken down the COVID-19 cases in my spatial data into the 3 classes, quantile classes, I'm now going to visualize the distribution of these classes. But before I go to that, I'll just want to show you how to do some descriptive statistics. So for instance, what if somebody asks you, how many counties in Kenya are at high risk as compared to medium and low? So in R, you can, it simply allows you to take your spatial data and use some of the dplyr functions that I had mentioned before, and you can come up with a quick summary, a table showing the distribution of high, low, based on the classification quantile that I've used before. And here you could see Nairobi is leading with 2,655 cases. So this data is somehow updated from last week. But basically, I just wanted to show you that you could easily describe your data, your spatial data in R using some of the dplyr functions. So now I will go straight into the use of T-maps. So I'm pretty sure most of you have used ArcGIS to just map some data, either raster, polygon, lines, and points. So I'm going to demonstrate how to use the T-map library to produce static maps. Maybe then later on, I will demonstrate in my other series, I will also demonstrate how to take these visualizations a notch higher and come up with interactive, animated 3D maps. But for this particular webinar series, I'm just going to delve into static maps, okay? So by virtue of our data containing continuous, so these are discrete and categorical variables, I'm going to show you how to develop a simple choropleth and a chorochromatic map using T-map. So just the same way the dplyr function has, if you want to do, if you want to add more functions to your R package, for the T-map, you simply use the additional sign. So the first thing is, depending on the data type that you have, for instance, here I'm using a polygon, so I'm going to use the TM shape function, and then I'm going to add a plus. So basically it loads in your spatial data into the T-map map layout. Then the next thing would be now in your data sets, what do you want to map? So the TM polygon function now allows you to basically choose the variable that you want to visualize, okay? And the same way, just taking into account, the various map elements, that need to be included in a map. So I'm going to do a title, then choose a color, legend site, and so on and so forth. And if I run this, the resultant output is what you can see on your screen, okay? So basically, based on the classification, on the COVID-19 classification had come up before, I've been able now to use TMAP to produce a simple map that shows the counties at medium risk vis-a-vis counties at low and high risk. And from this result, you could see as of last week, most counties were at medium risk. Medium risk being they have cases above 1 up to 47. So the good thing about R is you could easily reproduce this script and use it for your other functions. So basically, this is a simple chorochromatic map. I call it a chorochromatic map because it takes into account categorical values from my spatial attribute. So here it doesn't show the intensity of cases, but rather it shows the ordered values, the spatial distribution of those categorical ordered values on a map. Okay. Then the next thing I'm now going to highlight to you, which is synonymous to everyone, choropleth maps. Choropleth maps are good when it comes to visualizing spatial attributes that are either continuous or discrete. So something worth noting is most people call term choropleth maps as heat maps, which is not the case. Okay, so just take note that a choropleth map is not a heat map. So it basically allows you to map out the spatial distribution of now the COVID-19 cases across the county. So here I'll still use the breaks based on the quantile classification that I showed you before, and the resultant output is which will be later on be able to compare the two. Is this, okay? So basically, it has been able to give me the distribution of now COVID-19 cases, not the classification category that I'd come up with, but rather the cases across the country based on quantile classification. So here I've used the quantile breaks, which is what I had shown you before, basically breaking your data based on your normal distribution. And the other way of doing it is to just add a style function in your TMAP called quantile, which to me is also a simple tool, and it shows how R is robust in spatial analysis, because it doesn't have one way to do it. And this is something I appreciate about any programming language. Like, you could kill a rat using 1001 codes of line. So it still does the same, but then again using a simple line of code. So in order for now you as the audience to really appreciate the different classification systems of spatial data, I'll now apply the quantile classification equal Jenks and maybe I can also add the features later on. And then basically, using this line of code, you'll be able now to appreciate why it is very important for you to choose the right type of classification for your spatial data. So let me just run this, and then I'll use the tmap arrange function that basically brings all the maps. So the first map is I've classified the COVID-19 cases by quantile. The second one, I've classified the COVID-19 cases across the 47 counties into equal intervals. And then lastly, I've classified the COVID-19 cases into natural gens classification. And this is the resultant output that you can see. So in order for you to visualize your data for decision making or for any intended purpose, you can see that the type of classification really matters. So for instance, using the quantile classification on your left, you could see that we have at least a better representation of the number of COVID-19 cases across all the counties. But then again, if we were to go with equal counts, majority of our classes would be lumped up into one class, which is 0 to 531, which will somehow, yes, give you a spatial distribution. But then again, all your COVID-19 classes will be in that specific class. Then lastly, we have the COVID-19 gens. The map you can see in your far right, where at least it has broken it down into good classes, but also you could see majority of counties are in the class where we have 72. I think, yeah, 72 to 220 cases of COVID-19. So be your own judge on which of the classes that you need to use before you make a choropleth map or you make a chorochromatic map for decision making in R. But for me, I'll still stick with quantile because it somehow gives you a good representation of the spatial distribution based on these classes. Okay. So like I had mentioned before, R through the tmap package, R allows you to basically add more map elements on your map. The same way you have a map layout in ArcGIS or a map layout in QGIS or any GIS software of your choice, the tmap also allows you to add those map elements. So it's basically you're adding more functionalities, more styling into your map to make your map more, to give it a better visualization, okay, for your specific audience. So for this particular case, tmap as an R package allows you to use a set of functions such as TM layout, which basically gives you a way of adding more functions in your layout. So if you want the what is it called, the fill out frame, okay, then again if you want to add more text into your map, so you want to label text, you can use TM text. You can also do a scale bar, compass, you can add your title, and so on and so forth. Okay, So just using the natural, no, using the quantile breaks classification, using this series of lines of codes, TMAP can give you such a visualization. I'm not too sure if it is visually appealing, but clearly you could see you have some elements of labeling in your map. You can add the map frame, you can add a scale bar, you can add a north arrow, and also you can add a table, basically a graph showing the distribution of your spatial data based on the classification type that you've used. Okay, so this is a clear example of using TMAP to make a choropleth map, a simple choropleth map that shows the distribution of COVID-19 cases in Kenya. Okay, and this is the simple code that I've used. So for labeling of my map, I've used the county names, the size of the font. So just like any other programming language, it allows you to customize it even further and further and further, which now improves the map even a little further. Okay, so the compass position, I've put it in this side, on this side. The legend title, yeah, doesn't look that good, but I've decided to put the legend outside, but still you can reduce the size of the legend and fit it inside your map. And the position, I've put it on the left, but on my left, but at the top. So basically you can add more functions to the map. Then just like any other GIS software, once you've made your map to your desired output or to your desired styling, the next thing would be to export it, basically. So same thing in TMAP, you can easily export your map, but the good thing about the export functions in TMAP, it allows you also to give more specifications to how you want to export it. So like for instance, it allows you to choose the working directory where you want to.
I had my chat open.
Where you want to store your map, and then depending on how you want to export your map, just like in QGIS or ArcGIS, there are instances where you want to export it as a PDF, a PNG, JPEG, and so on and so forth. It also allows you. So for here, for my specific demo, I'll want to export it as a PNG, and then I'll give it a file name. Okay, so let me give it let me give it a file name. Okay, I'm not supposed to do it on the fly. COVID-19 cases. Yeah, this is last week, 2020. Okay, then I can specify also the width and the height. Okay, and also the units. So in inches, and also the resolution. Okay, so in most researches they usually advocate for 300 dpi resolution. So you could also come here and say 300. Okay, then prior to you running the exporting your map in R, it always wants first of you to run the code that contains your map. Okay, so here's my TMAP code. So this is what is going to be pasted in my working directory, and then once my map has been copied, I've asked R to close the map that has been pasted in my plot. in my R plot window. So if I run this, yeah, so the green line has ended. So let me just go to my maps, and there you go. So you could easily see that I've exported the map in PNG, and the DPI is pretty good in the sense that you can zoom in, you can use it for documentation, and put it in whether you're publishing an article or you're writing a newspaper article, you can easily embed it in a web page. See, based on the resolution that you've set aside. So that's basically how you export your map. So you can export it as PDF, JPEG, and so on and so forth. So another thing about R is just using this simple line of code, you can create your own customized functions. So assuming you had over 20 variables that you would want to map out from your spatial data, so you can easily come up with a function. They always say in programming, if you're doing a thing once, you do it, write the code. If you're doing it twice, write a function. If you're doing it more than twice, you write a loop. Okay, so you could easily customize your code and fit it in a loop, so that at least for better reproducibility of the same products over and over again, you can easily now come up with a TM shape map looping that will easily produce maps even in your spatial data set that has over 100 columns in one go. Then the next thing would be, I would now try to demonstrate to you how to compare two maps together using the tmap function. So here, I'll just show you how to do gridding of two maps side by side for better comparison. Okay, so you might have the same you might have two attributes in your spatial data that have different information, but then again you'd want to somehow visualize this data in one go. So you can also do that in tmap by using the push viewport, okay, functions, which you can put them side by side. Okay, like here I've used tmap to basically show the COVID-19 cases against the COVID-19 categorization using the quantile break that I had used before. So here it is, and if you want to still export this map, the procedure is the same. Just set your working directory, set the parameters on as to how you want to export the map, if you want to export it as PNG, JPEG, and so on and so forth, and then run the code in the middle, then export it in your directory. So if I just run this code right now, which I shall be able to share with you this code for better replication. So the green line still shows that it's running. Okay, if I go to my working folder, there you are. So you can also have side-by-side choropleth maps in R. Okay, so here you can customize the grids further, even to have more than 2 layouts in one. Okay, so then lastly, I'm going to quickly show you how to come up with a graduated symbol map. So a graduated symbol map is basically a map that shows, you know, symbols such as circles, squares, but the symbol values are somehow, you know, graduated based on the value that is contained in your data. So for instance, in our COVID-19 data, where we have many cases, you would see a bigger circle. And where you have less cases of COVID-19 would have smaller circles. So it's still a map, but it takes into account, you know, graduated symbols. So graduated symbols, as opposed to choropleth maps, is that they give you some elements of clustering, dispersion, linearity, and also gives you some sense of general pattern of distribution. Okay, so here I'm going to use the mathematical proportioning, where like I said before, higher values have bigger circles. Okay, so you could also implement the same in R using still the tmap package. So here still using my variable, which is number of COVID-19 cases detected, I'm going to use a function called tm bubbles. Okay, so it gives you a set of bubbles or circles, and yeah, so if I run it, excuse me, the resultant output will be like this. So this is just a basic graduated symbol static map in R, where you have wider number of circles. So this is where we have so many number of COVID-19 cases. So for instance, in Nairobi, you have over 2,000 cases, followed by Mombasa, and the other one is Busia. And you could easily see from this map, you could easily see the circles. Okay, so basically this is the graduated symbol map on tmap. And how to export it, it's still the same way as exporting a choropleth map, a chorochromatic map, two side-by-side maps. So you set the working directory, file name. So here I'll say graduated symbol. At the moment, it's only the Daily Nation, Kenya, that are using graduated symbols for making a COVID-19 map. So if you go on their WhatsApp page, you'll just see the very fancy graduated symbol maps. Okay, so there you go. I'll put it some styling. I'll put it as red. I won't go into the nitty-gritties in the interest of time. But there you go. So it's being saved in my output folder as graduated symbol map, and here it is. So 300 dpi resolution, and if I zoom in, yeah, so here I can see the symbols where we have few cases of of COVID-19, definitely the symbols are going to be smaller, like Narok. And like I mentioned earlier on, where we have more number of COVID-19 cases, like Mombasa, you have a bigger circle. Kilifi, the same. But when you compare the Taita Taveta, Kilifi, and Kwale, Taita Taveta has the least cases, hence it has the smallest measurable symbol. So if you want to learn more on how to make static maps in R, Paula Moraga has a nice book down. So here's the link. Then we have Lex Comba is also one of the people I follow. So he has also come up with R book down showing how to use besides TMAP, even Gplot. And then we have Mark Zonzi, who has also come up with a series of book down on how to basically generate maps using R. So that's it from me. I think maybe I can allow a few sessions, some Q&A. But basically, this is what I really wanted to share out to everybody, that truly and indeed you can clearly use R to visualize your spatial data, and you can come up with good maps, probably even better maps than the ones I've demonstrated to you. So it's now up to you to take your imagination and come up with even far much better maps than I have demonstrated using my simple line of code. Yeah, so maybe at this juncture I can take in a few questions here and there, and then maybe we could conclude and discuss the next series on how to use R for interactive R, shiny maps and shiny applications and whatnot. Yeah.
Thank you so much. Thank you so much, Michael. This was a wonderful presentation. So maybe you can just go a little bit on the chat box. There have been some questions throughout the session, trying to respond to them one by one. Also, if anyone would like to do a session, to ask a question, just unmute yourself and or if you feel free to write on the chat box, and then Michael can respond to you for the next 5 minutes. Then we'll jump quickly into the next few sessions we have with Michael. Maybe just to recap some questions to you, Michael. There was a question by Lillian when she was asking, what data did you load to the KE exposure data spatial data frame, and whether it's freely available? And there's also another question from Caroline asking about, can you talk a little bit more about the prevamp package as well? There was also another question on how can this analysis be upscaled to include other data sets, including to the data sets you have presented.
Okay, so let me start off with the first question. How did we get this data? Like I had mentioned before, this data is, yes, freely available from the Ministry of Health daily press releases. So you can clearly what we did at the Kenya Red Cross, we have kept track of COVID-19 cases since March. So we, based on whatever information they give us, we have a database on our own where we feed in all these incidence data based on the Ministry of Health press releases. But for those of you who would want the compiled data sets in a shape file or in a data frame, yeah, we could easily share it to you because it's out there, but somebody, for us, we just collected and put it in a well-structured manner. The other question was on the, which package is that?
Prevamp. There was a question of Prevamp. Yeah.
Honestly speaking, haven't heard about it, but like I mentioned before, we have an array of R packages that can do the same. So ggplot is one of, tmap is one of them. We have ggplot, and I think prevamp is also the other package. So it's good to explore other packages that can do the same. Okay, yeah, haven't used it unfortunately. Then the other question is yeah, which website? I think I've responded to that. There was another one where they were saying if we could upscale this, I think it's Collins Asega. If we could use data from Kenya National Bureau of Statistics, yes, we can also use other data sets and produce similar maps like I've presented. So you could use other data sets and come up with the choropleth maps, chorochromatic maps, and graduated symbol maps. The other question was on, I think, yeah, so it's true. Hamadu has said, instead of me using if-else statements, I can use the case when to replace the nested if-else statements. Yeah, and I think that's basically it from the chatbot, unless there's something else that I've missed out. Yeah, last one. The Kenya exposure is basically a polygon, but with the SF package, you could easily transform it to points, to data frames, yeah, and so on and so forth. Any other question?
I don't know if I can. I have a quick one.
Yes, Amadou.
Yeah, I mean, I really enjoyed your presentation, and it's really. I'm also in the humanitarian space, and I always have a high opinion of Red Cross and seeing what you did. I mean, it's just like really amazing. Just my question is like, do you think R can be used, for example, as a full GIS tool, for example, for the work you are doing with Kenya Red Cross, or sometimes are you mixing it with other tools?
Yes, that's a good question. Let me switch on that. That's a good question, Amadou. R is such a powerful tool, and in our engagements in GIS, we've come to realize that even in some of our dashboards, we've primarily used R from the first step up to the last. So it can complement the other GIS softwares, but I wouldn't advise to use it primarily as the only GIS software. Okay, so where it has come in handy in our daily works is basically one, automation of workflows. So basically, if we have a series of things that we have to do repetitively, we use R now to automate most of our spatial workflows. The other thing that it has come in handy is on visualization. As we are speaking, we have about four dashboards that are running using R Shiny software. So, which makes it a strong tool for our case. Even in one of our dashboards, it's like we are building a national system for flood impacts, flood analysis, and it's running in R. But I wouldn't advise to use it as the only sole GIS software. You can use it with other GIS softwares, other programming languages, yeah, such as QGIS or Python.
Great. Do we have any other questions? Our 5-minute window is almost up.
Hello.
Yes, Taye.
Yeah, hi. Thank you for your lectures. It's very, perhaps I would just say this is spatial analysis made easy, because it's very easy to understand. I really so much appreciate it. Yeah, my question is more about it's more kind of futuristic, because I'm actually here to learn complex and advanced spatial analysis. So I would like to ask that in the subsequent series in the future, are you going to include analysis such as spatial regression, Bayesian statistics, or it would not be covered in this series?
Thanks, Taye, for that. Oh, Nombulishelo, you can take that question.
Maybe I can answer on that. Definitely, Michael will be able to answer on his particular project. But Taye, how our series are designed is around a certain project idea, and this was just giving the community an outlook on Kenya Red Cross response to COVID. If it includes Bayesian networks, Michael will be able to inform us. But we do have another series coming up on like version 2 on spatial analysis, which covers multi-level regression modeling, OLS regressions, Bayesians, and the like. So stay tuned, keep in touch.
Okay.
Yeah, so besides visualizing, you could take it. You can take R spatial analysis a notch higher. Like even I can attest to everyone. Even in my master's project, I used primarily R from step A to Z, and it's good to incorporate prediction models. You know, when you're handling more than one spatial variables, and you'd want to investigate the spatial relationship of these variables, you could easily use R to run spatial regression models, and spatial models, and yeah. And I hope that we'll have a session with women in GIS in the coming futures, where we'll also demonstrate how we are using spatial models at Kenya Red Cross using R, of course.
Okay. Yeah. Thank you. But I've really enjoyed the lectures. It's really like very simple to understand. You are a good teacher.
Thank you so much. And my code, I shall share it with you, all of you, including Taye. And for those of you who would want to reach out to me, I don't know, maybe I can just paste my my work email. And also for those who would want to collaborate or engage with Kenya Red Cross on use of GIS. My email is always there. I shall be able to respond to your emails, and then we'll see how best we could collaborate.
Great. So yeah, there is Michael's email. Like he mentioned, the video, the data pack that he used, as well as the code, the R notebook that he used will be available on Women in GIS, on the Women in GIS website under projects. And expect that email on Monday. We're just going to do some editing on that. But very quickly, as he stops to present, I want to give you a bit of a feedback or background on why we have the After Hours series, and just to have you guys keep on coming back, because we have very many interesting industry experts like Michael, who are really open to showing the community what they do in their day-to-day professional workplaces, and how you can take advantage of that, for learning from them, and be able to use that in your own projects or in your own space. So I don't know if Michael, you're done. I can present very quickly, just to wind up on the AoH series. And thank you so much, Michael, for taking the time. He will extend this project on 15th July, sorry, 23rd of July. That's 2 weeks from now. And then you can count another 2 weeks from now, which is the last series. Wait, do you want to talk on the next July 23rd before I quickly switch over?
Yeah. So it started off with visualizing spatial data using static maps. Then the next series would be, we now go into interactive maps. So I'll demonstrate how the Kenya Red Cross Society is using R packages to visually interactive to come up with interactive maps using packages such as R leaflet. Then the last final package would be now how to share your map to a wider audience through a web-based URL. So I'll be talking now about how to make simple R Shiny or Flex dashboard applications that can easily see, that can help people to share out their GIS projects for a wider audience. Yeah. Over to you, Nombuyiselo.
Thank you so much, Michael. I don't know if you guys can see my presentation.
Yes, we can.
So yeah, that was the series, the second series on our analyzing spatial analysis with R. Thank you so much, Michael, from Kenya Red Cross in conjunction with ICHA. They were working on the COVID response project for Kenya Red Cross. Very briefly, Women in GIS is a consortium of advocates, academics, government, and private industry stakeholders who are interested in advancing the presence of women, or rather gender parity, in the geosciences and tech industry. We foster relationships with among community members and industry, such as people like Michael. So what's up next? We have the third part of the series, which is scheduled for 23rd of July. And please take this down, our link, and follow through the slides and try and get the code up and run it on your side, so that you can be able to extend your project on the next series, which is scheduled for 23rd. It will be an extension on this project. And the idea behind that is to get our community to a ready-made project by the end of the 4 sessions, that they can be able to implement and share amongst their community or on their portfolios on how they were able to implement Kenya Red Cross, a skeleton version of the Kenya Red Cross project. And also, if you're very much interested, please reach out to Michael if you have an idea that you would like to expand on the implementation and just help them really build up their project through open source. You know, we're all open source and we all want to learn from each other. So the other project that's lined up is this month is teenage pregnancy visualization challenge, which is similar to what we have with our AoH series, which is the After Hours series. But in this one, the community, you just request us at info@wigisk.co.ke the data, and then you can be able to do some interesting analyzation and visualization based on all the skills that you have picked up in all of our other series, and be able to present that final product by 29th of July. And we'll have a summary insights on, or webinar on, what we gathered from the community and their perception and the analysis for teenage pregnancy. So I want to just give up a big shout out to Michael, as well as the team behind this webinar series. We have our leads there, Caro, Yario, and Jerry, myself, a strategic advisor, as well as our associates, for making this possible and for connecting us with interesting industry leads all the time, and allowing us to be able to get people like Michael on board to show us the skills that we've been able to learn. So yeah, if you would like to become a member, contribute, volunteer, reach out to us again at info@wigisk.co.ke. You can spread the word about our webinars, become a member, host an event. Just reach out to me. I'll leave my details on the communication section. And yeah, you can volunteer. Want to host an event, reach out to us. We're free and we're open to learn. So I would like to end by asking Michael to say a few words as he closes up the session.
Yeah, thank you everybody for attending this session. You can always reach out to my email for further engagements, and thank you, Women in GIS, for this opportunity. Looking forward to the next webinar series on how to use R. Thank you so much. And stay safe, everyone. Bye-bye.
Bye.
Thank you, Michael.
Bye, everyone.
Thank you, Michael. Bye. Thank you. Bye. Michael.